Hi everybody. Today we are talking about private key cryptosystems. They're also called symmetric algorithms, or we can otherwise talk about symmetric key encryption. Remember what we are talking about. Alice wants to send a message to Bob, and she'd better send an encrypted message because she does not want Chuck to read the message. Moreover, we need to make sure that Bob will be able to retrieve the original message. In cryptographic language, that means that we want Bob to decrypt Alice's encrypted message. Private key cryptosystems are certainly the fastest way to achieve this. They work in the most intuitive way. The encryption key is a function, not any function, of course, but there are many which work well. Please check the links in the description below if you want to see some examples. We will recall some of them at the end of the video. This function, as expected, is taking the plain text, that is the message that Alice wants to send to Bob, and it transforms it into an hidden text that we call ciphertext. The decryption key is the inverse function, usually denoted by f-1. In particular, that means that our function f should be invertible. Of course, we expect f-1 to take the ciphertext and to transform it into the original message sent by Alice. So Bob will be able to read the message. Now, the whole process goes more or less like this. At first, we have Alice. She writes a text, she takes the function f, and she sends to Bob the hidden message called ciphertext. Bob receives the ciphertext, he applies the inverse function to the ciphertext, and in this way, he can recover the original message, here called text again. If Chuck happened to read the ciphertext, he wouldn't understand anything, because without the function f, that is the private key, he cannot retrieve the original text. So that's over for him. In general, we summarize a private key algorithm with this short diagram: text, function f, ciphertext, f-1, and text again. Let's now discuss some properties of private key cryptosystems. First of all, the computation of the inverse function f-1 should be easy. And this is not an empty claim, because many invertible functions in mathematics have a very complicated inverse, or at least it's very difficult to compute their inverse. For that same reason, we want only Alice and Bob to be allowed to know the function f. Otherwise, anyone in possession of the function f would be able to read Alice's messages. Some not too complicated examples, but definitely not trivial, are certainly the Digraph Transformations and the Enciphering Matrices. In the description below, you will find the link to the videos describing those particular cryptosystems. Then we have some more famous examples. By this we mean cryptosystems which are used by companies, institutions, or governments on a daily basis. We definitely want to mention the DES, the Data Encryption Standard, which was the most used private key cryptosystem until the early 2000s. Then we have the Advanced Encryption Standard, AES, which has little by little replaced the DES, because simply it is considered safer. So, are private key cryptosystems perfect? Not at all. If Alice lives in Canada, for example, and Bob in New Zealand, how can they share the private key, the function f? Well, Alice can take a flight, and the next day she will hand-deliver the key to Bob. This is one way, of course. Or they can use a key exchange protocol. For this, we will need to know public key cryptosystems. But that's it for today. So stay tuned, because that's only the beginning of our journey. Please don't forget to like, comment, and subscribe. Thank you very much again. Bye.